Hey, how are we doing today? Mr. H here. We are going to start Unit 4 today with adding, subtracting, and multiplying of polynomials. I think you're going to like this. It's a nice, easy way to start into things. Basically, all we're going to be doing, like it says here at the top, is to add or subtract polynomials. We're going to add or subtract the coefficients of the like terms. Like terms basically just means same variable and exponent. Okay, you can use the vertical or horizontal format. Now, I'm going to be honest. I am a fan of the horizontal. I'm going to make this perfectly clear out there to begin with, and you'll kind of see why here. But I'm going to show you both because, again, you've got a choice to make on your own here. So when we're looking at adding the polynomials vertically, here's the important fact about doing vertical. You need to really watch and make sure that the exponents are the same, like that these are both x to the thirds, these are both x squared, these are both coefficients. Because if I just line them up and I have x to the third under x squared, that doesn't work. They're not like terms. So as long as I make sure they're like terms, and as long as I remember that any coefficient is going to be a 1 if I don't see one there, now I can look and I can go, okay, so 3 plus 1 is 4, x to the third. Not x to the sixth, okay? We're not multiplying here. We're not adding the exponents. We're leaving them alone. We're just combining like terms. So 2 minus 10 is negative 8, x squared. There are no other x's to work with, so we just leave that as minus 1x. And then 8 plus negative 8, oh my gosh, negative 7 plus 8 is 1. So what we're going to do here is we're going to have that done. My apologies for the distraction there for a minute. I took care of it. Now, horizontal, okay, now it's just we're looking for variables and exponents. So I look here and I see an x to the third and an x squared and a couple of x's and things like that. So here's what I normally do. I look for the biggest exponent, x to the third, and that's the only one of them. So I'm going to check that off. I'll write 9x to the third. And then I go scanning. Do I see any x squareds? I do. That's the only one. So I write 5x squared. I check that off. Now when I get to the x's, I notice there's 2 of them. Colors can really start to help with these things to kind of make things jump a little more. So now I'm going to do the same thing I did with vertically. Negative 2 plus 12 is 10x. I don't change the variable at all. I'm just messing with the coefficients. And then finally, at the end, I have 2 constant terms. 1 and negative 4. 1 minus 4 is negative 3. Okay? All my variable terms are different. They have different exponents. And so I'm done. Choice is yours. Okay? Now, with subtracting polynomials, this is where I kind of take my stand with this whole thing. I can't stand this way, and here's why. It gets to be tricky because basically all this minus is doing is changing the sign on all of these. Now, if you remember that as you're doing, that this is minus 2x to the third, this is minus, that's plus, and this is minus, that's fine. If I'm forced to do vertically, here's what I normally do. I go ahead and I'm going to rewrite this bottom part, and I'm going to change the signs on all these. Because that's really all that this does. All the signs get changed. And then I rewrite my top one above it, and now I handle it just like the adding one. Because again, there's too many things that can go cuckoo down here. Dealing with the signs, trying to remember if it's 2 negatives, oh, that doesn't make a positive, it's more negative and things like that. Whereas you can get it back to something you know, and now I'm just adding. Okay, once I change all those signs. 8 minus 2 is 6. Negative 3 and negative 6 is negative 9. Negative 2 plus 1 is negative 1. 9 minus 1, excuse me, is 8. And I'm set. Okay. A little more work doing it that way, but I think it's worth it to make sure we're keeping things straight. Now, when I get to 4 doing horizontal, it doesn't mean this doesn't come without its own issues. Because here what I would do is I would take that negative, and I'm going to distribute it all the way through. Now, if you don't want to rewrite this, you could just change the signs right in there, but that can get a little sloppy. So nothing changes here on the first one, but this negative is going to change signs. Positive to negative, positive to negative, negative to positive. And now I would do it just like I did the other horizontal that I had up above. I'd say, okay, where's my biggest exponent? 2. Ooh, there's 2 of them. 2 minus 3 is negative 1, or just negative x squared. The 1, it really doesn't make a difference one way or the other. Okay, x's 3x, and remember there is a 1 in front. So 3 minus 1 is a positive 2x. And then that's my only constant term. We always go biggest to smallest. That's what standard form tells us. And so as we do that, it's just, again, it's detail work. It really is. Now, when we get to multiplying, we got to do a little bit of a rollback to when we were doing our exponent rules before. Okay? When you're multiplying, you add the exponents when there's variables involved. Okay, just kind of a little flashback here. So when we're multiplying, okay, I absolutely abhor vertical when it's multiplying. So I'm not going to do it that way. I think you're heading for trouble. So here's what I would suggest. We're going to create a box, okay? And the size of the box is going to be dependent on the size of our polynomials. So in this case, I have a binomial, 2 terms, which I'm going to put along here. Now I'm sitting here going, I think that's positive x. I think my pen just messed with it here. Yeah, it did. Okay. So that's positive x. So x minus 3. And then I'm going to take the other edge, this negative x squared plus 2x plus 4. And if you add 3 by 2, it doesn't matter. I just want each of my terms along an edge. What I'm also going to do to help myself out is I'm going to stick those 1s in as coefficients. So here's how this works. We're still going to multiply. It's just going to be the edges of the box. So like 1 times negative 1 is negative 1. And remember, okay, there is an exponent on those x's. It's 1. And I'm going to add the exponents. 1 plus 2 is 3. And I just keep moving along. 1 times 2 is 2. On my exponents, 1 plus 1 is 2. 4 times 1 is 4. There is no other x, so I just leave my x. And then I move to the bottom row and I do the same thing. Negative 3 times 1 is positive 3. But there are no other x's, so I just keep my x term. Negative 3 plus 2 is negative 6x. Negative 3 times 4 is negative 12. So I've done all my multiplying. So the last step, I can't just leave it in the box. Just like we do when we're writing it before. When we're doing standard form, we're going to go biggest exponent, negative 1x to the third, check. There's my x squareds. Now again, once we've multiplied, we're not multiplying anymore, okay? We're just adding and subtracting once we're in the box. So 3 plus 2 is 5x squared. Do not mess with the exponents anymore. That's done once the box is filled. And we just keep working. Negative 6 plus 4, negative 2x, and the minus 12. Is it wrong if I don't put them in order, greatest to least, as far as my degree goes? No, but you know how picky some of these programs are. So again, we want to get it into standard form here. And so I'm going to do the same thing here on 6. Now, I'm going to show you another way, okay, when it's horizontal like this. I still think this is the best. It's organized better. It's not as sloppy, okay? But I am going to show you another way because people like having different ways of doing things. All right, so I'm going to get my little 1s on those. If it's horizontal, I can do the distributing. I could say, okay, So x to the first times 3x squared would be 3x to the 1 plus 2, or 3. Negative 2 times 1 is negative 2. 1 plus 1 is 2. X to the first times negative 4 is negative 4x, or negative 4x to the first. Okay? So I just distributed that x to each one of these the first time. Then what I would do is I would take the negative 3 and I would multiply it and distribute it through. Negative 3 times 3 is negative 9x squared. Negative 3 times negative 2 is positive 6x. And negative 3 times negative 4 is positive 12. So this would be the same thing I would get if I made a box and would have put x minus 3 and 3x squared minus 2x minus 4 along here. These would be in there. From here, it's the same thing. Go looking for your biggest exponent. When you find it, write that first. Then x squareds, I have 2 of them. Again, no more messing with the exponents. We're just combining like terms. Negative 2 and negative 9 is negative 11x squared. Negative 4x, positive 6x. Negative 4 plus 6 is 2x. And our constant. Again, either of these ways, the box or doing it with the distributive property works. I'm a fan of this because I don't like having all these lines going all over the place, but if that doesn't bother you, go for it. Okay? So now, now it gets interesting. Okay, number 7. Hardy, is there like some 3D box you can do with this? No. Okay? We're going to do 2 sets of parentheses at a time. So here's what that's going to look like. I'm going to go back to box mode on this. If you still like distributing, keep distributing, okay? So I'm going to do these 2 first. If you want to FOIL them out like this, you go for it. Let's see if we get the same thing. Put those exponents on there at the very least. And so now I'm going to sit and I'm going to go, okay, x and x is x squared. Add my exponents. I meant to change colors here. Just a second. Okay. X times 4 is 4x. If you want to put 4x to the first, that's fine. Negative 1 times x is negative 1x. Negative 1 times 4 is negative 4. So here's the kicker with this one. X squared. 4x minus 1x. 3x minus 4. But I'm not done because I still need to get this x plus 3 in there somehow. So how am I going to do this? I'm going to create one more box based from my answer here. So if you've got room, I'm going to go ahead, take my last answer, put the x plus 3 here with it, and keep going. Now, if you're a fan of the distributive property and you did your distributing here and have an answer, and then you just want to put parentheses and then the x plus 3 and do it like we did in number 6, you'll get the same answer. Okay, it's just a personal preference at this point. So here, I'm going to add my exponents, x to the third. So we got plus 3, 1 plus 1 is 2. Negative 4x. And then do the same thing across the bottom. 3 times x squared is 3x squared. 3 times 3 is 9. So our coefficients, our numbers in front, we're still multiplying. It's just the exponents that we add. And then 3 times negative 4 is negative 12. And my last step is to clean all this stuff up, get my like terms together here. I'm going to make sure I don't run into my head with the answer. So x to the third 3 plus 3, remember, coefficients don't do anything fancy, don't multiply them. We're just combining like terms at this point. 9 minus 4 is 5 minus 12. Okay? So again, is there some time involvement with this? Yes. Yes. This is very detail-oriented. This isn't as much of a hard concept as it is just getting used to the detail. So then, when we're multiplying, now here you're going to have some options on some things, okay? We've done difference of squares before. We've talked about that. Square of a binomial. Now, there's a pattern to this, but along with the pattern, we can go back and go old school. So I'm going to, again, give you options. You choose how you want to do it. If you want to follow the pattern here, okay, square of a binomial. This is like my A term. This is like my B term. And so what I would do is, this binomial square, I would square my A term. So I'm squaring my first term. And then I'm adding 2 times the product, which means I'm doing 2 times my A term times my B term, and then plus my B term squared. Now, some of you are like, that's a lot to keep track of. But as you get to know the formula, okay, the kind of the pattern, it can go really quick in your head, because just watch this for a second when I simplify it. 2 times 2 is 4x plus 4. Here's what you start getting into your brain. Square my first term, okay? What's the product of these two? Well, 2 times x is 2x, double it, that's 4. Square my last term. Square it, double it, square it. And so you can start working through it that way. Now, if you don't want to do that, if you're like, I'm old school, I want one way and one way only, skip this pattern stuff, here's what you would do. Either you write out 2 sets of parentheses, x plus 2, x plus 2. You can do the distributing and FOIL it out. Or you can do it in your box. Add my exponents. X times 2 is 2x. 2 times x is 2x. And multiply it out and check out what happens. X squared. 2 plus 2 is 4 plus 4. I get the same answer either way. It's up to you. Now, to me, it's worth it to work on memorizing the pattern, square it, product, double it, square it, and just be done, rather than have to go through all this. Okay? So I'm going to show you the pattern one more time, because I really think it's going to be worth your while. Again, you always can go back and just do 3x minus 4, 3x minus 4. Do it with a box. But if we do the pattern, okay, let me get my colors here again. So this is A. This is B. Now, here's what I want to make stress at this point, okay? When we're doing this, you've got to keep in mind that my B isn't negative 4, okay? Here, my B equals 4. You're like, but it's negative there. The signs get taken care of in the pattern. So whenever you see plus or minus here, you ignore that and just take the value that's there. The sign gets taken care of here if you're doing the pattern. If you're doing the box, you would still just keep the numbers in the box. So let's take a look at this both ways and see how this goes. So if I'm going to do it with the pattern, now it's a minus in the middle. So I've got a squared, so square my first term, minus 2 times, and again, it looks worse when you write it out, 2 times A times B, plus B squared. Okay. So now I squared the 3 and the x squared, 9x squared, Multiply all this stuff together. So 2 times 3 is 6, times 4 is 24. So minus 24x plus 16. So think about it for a minute. Square my first term. 3 times 4. Okay, if you want to do the negative here, it'd be negative 12. Double it's negative 24. And negative 4 or 4 squared is 16. But if you use the pattern, you need to think this through. Square it, multiply them together, and double it, square it. Or you can do your little box with those. Up to you. Totally up to you. Now, oh boy, cube of a binomial. Now, this is a little different of a story. This one's a little trickier. I'm going to walk you through the pattern. Okay? I'm going to walk you through the pattern, and then I'm going to show you how you would do it if you choose not to use the pattern. Okay? We're still going to go like we did before. A is going to be my first term. B is just the number of that second term. The plus or the minus just tells me what the pattern is going to look like. And so here's how this works. Notice on my A's, a to the third, a to the second, a to the first, and then a to the 0. It goes away. So when I'm writing this, and again, this is just me, what I like to do is I like to write all my A's down first. So I'm like, okay, so a to the third, use the parentheses. A to the second. You're leaving space in there. Yes, I am. I'm doing this on purpose. A. Okay? A to the third, a to the second, a to the first, then there's none left. Notice, though, with my B's, it's the opposite. No B, or B to the 0, B to the first, B to the second, B to the third. So what I've had people tell me before, and again, I try to listen to all these people's ways of doing it to make it a little bit easier. So here's what I've learned to do. A to the third, a to the second, a to the first, a to the 0. B to the third, B to the second, B to the first, B to the 0. And then the only thing I got to remember is these two middle terms each get a coefficient of 3. Now, if you're more of a memorizer of, I can memorize it just straight this way, that's fine. Because here's the other thing I want you to take note of. Every single term I have here has a power of 3. 3, 2 plus 1 is 3, 1 plus 2 is 3, 0 plus 3 is 3. So if ever you're wondering, you're like, did I mix them up? Just look, do your exponents in each term add up to 3? If they do, great. Okay. And then it again just comes back to doing my multiplying. Now again, here I would take a little bit of a half extra step here, because 2x squared, if I distribute that, would be 4x squared. So 3 times 4 is 12, times 5 is 60, x squared. Here, 5 squared is 25. 3 times 2 is 6, times 25 is 150x, and 5 cubed is 125. Now again, you're going to have that pattern there to be able to work with. Jot it down on a piece of paper, keep your notes out. Again, if you want to be the creature of habit and you don't want to deal with it that way, I would try to get used to it this way, and there's going to be some stuff going on here in the background. We're going to kind of work through it here a little bit. So here, what can I do otherwise? My other option is to write this out 3 times. Mercy. And like we did on the front, pair them off and work them. Distribute, box, whatever you're going to do. So if you're like, okay, so let's get my box here. Again, distributing is fine as well. And I would just work through it that other way. Multiply my coefficients, add my exponents. Multiply my coefficients. There are no exponents to add because there's no other x term. Multiply my coefficients, multiply my coefficients, And I get 4x squared. Negative 10 and negative 10. I owe somebody 10 bucks. I borrow 10 more. I owe them 20. Now again, I'm not done yet. I still have one piece left. So I go ahead, and now I have this one last box that I'm going to fill in. And again, multiply coefficients, add exponents. Multiply coefficients, add exponents. Multiply coefficients, no exponents to add. Multiply coefficients, multiply coefficients, and check this out. Oops, move that up a little bit. 8x to the third, negative 20 and negative 40 is negative 60x squared. Oh, did Hardy go bonehead? Oh, we're going to have to look at this in a minute. Hardy might have gone bonehead on something. This does happen. It does. I'm not going to lie. Not going to lie. 100 plus 50, or let's see if Hardy did something else here in a minute. Nope, not so far. 150x minus 125. Okay, let's see what happened here. What did Hardy miss that changed things up here? Hardy didn't copy the formula right. Okay. See how this says minus? Hardy paid no attention. Didn't make that minus like I was supposed to. Okay. Now they're the same. So I didn't really make a huge boo-boo, but I did make enough of one. Again, detail error. This is going to be, that's what this unit's going to be about. It's going to be about, am I making detail errors on things as I'm doing them? And hopefully we don't make a ton of them. So those are my options here. Pattern versus double box, double distribute, whatever you want to do. Last piece. Got to get an application in here. We're trying to raise money for your trip to Spain. Ooh. And you decide to sell cookies. The revenue, okay, the money you're making from selling X cookies is given by this equation. Okay, 2.5X, which means you're charging $2.50 per cookie. They better be some really good cookies. The cost for making X cookies is given by the equation X plus 32. Now, maybe that 32 is the cost of your supplies, the cost of boxes, whatever, we don't know. So, what are you selling each cookie for? It doesn't mean you're selling it for money for a trip to Spain, okay? That revenue number is telling you how much am I getting for every cookie. That's basically what the question's asking. What are you selling it for? Write a profit function. Okay, profit is revenue minus, oops, I almost used another word for revenue. Revenue minus cost. Okay, how much money did I bring in versus how much money did I have to pay for materials and supplies and things? So revenue is 2.5x revenue minus my cost. Now, it's critical that I use parentheses. I always tell people, when in doubt, put parentheses in. Why? Because if I don't put the parentheses, I'm not going to be subtracting the 32. I would just be subtracting the x, not the x and the 32. And don't stop here. Let's simplify it. 2.5x, and that'll be negative 1x minus 32. And if I combine my like terms, 2.5 minus 1 is 1.5x minus 32. Okay, this is my profit function. For every cookie I sell, I'm going to make $1.50, but then that $32 and whatever it cost me to get started or something is going to come out of this. So when it says, what is your profit for selling 381 cookies, that 381 is my x. So 1.5 times 381 minus 32. Too early in the morning for me to do that in my head. $539.50. Okay, so your first job with this stuff, if you take a look at your tracker and you're kind of starting to look ahead a little bit, okay, is to be working on some of this paper and pencil practice. Now again, there's a key right on the Google Classroom if you don't have the ability. If you don't have this to have every single one, maybe you do all the evens or all the odds. Okay? Just the evens or odds, then check your work. If you're going good, good. You're probably good. You probably don't need to do every single one. But if you're getting some wrong in an area, maybe you practice those a little bit more. Okay? But again, it's just some of that same basic stuff, and it's starting to get us ready for when we're doing the quizzes, the Delta Math, for the actual exam scores that we're going to work through. So hopefully this has worked well for you. If you have any questions, shoot me an email or mention during the meet, and we'll get you set. Have a good rest of your day.